The globe of the Earth is a magnet. William Gilbert, 1544–1603. By the late 1500s, ships' captains already relied on magnetic compasses to maintain their course across the oceans. Yet no one knew how they worked. Some thought the compass needle was attracted to the North Star, others that it was drawn to magnetic mountains in the Arctic. It was English physician William Gilbert who discovered that Earth itself is magnetic. Gilbert's breakthrough came not from a flash of inspiration, but from 17 years of meticulous experiment. He learned all he could from ship's captains and compass makers, and then he made a model globe, or Tarella, out of the magnetic rock lodestone and tested compass needles against it. The needles reacted around the Tarella just as ships' compasses did on a larger scale, showing the same patterns of declination, pointing slightly away from true north at the geographic pole, which differs from magnetic north, and inclination, tilting down from the horizontal toward the globe. Gilbert concluded, rightly, that the entire planet is a magnet and has a core of iron. He published his ideas in the book De Magnete, on the magnet, in 1600, causing a sensation. Johannes Kepler and Galileo, in particular, were inspired by his suggestion that Earth is not fixed to rotating celestial spheres, as most people still thought, but is made to spin by the invisible force of its own magnetism. Stronger reasons are obtained from sure experiments and demonstrated arguments than from probable conjectures and the opinions of philosophical speculators. William Gilbert. In context. Branch, Geology. Before 6th century BCE, the Greek thinketh Thales of Miletus notes magnetic rocks, or lodestones. 1st century's Chinese diviners make primitive compasses with iron ladles that swivel to point south. 1269 French scholar Pierre de Maricourt sets out the basic laws of magnetic attraction, repulsion, and poles. After 1824 French mathematician Simeon Poisson models the forces in a magnetic field. 1940s American physicist Walter Morris Althusser attributes Earth's magnetic field to iron swirling in its outer core as the planet rotates. 1958 Explorer 1 space mission shows Earth's magnetic field extending far out into space.